Hello, my dear students. Let us take one more example on columns and struts. Let us take this problem. A column of timber section is 200 mm by 300 mm and 5 meter long. One end of the column is fixed and the other end free. If the Young's modulus of timber is 17.5 kilonewton per millimeter square, determine crippling load and safe load if the factor of safety is 2.5. Okay, here it is asked to find the crippling load. Okay, here actually the data is given only this area, so cross section and the Young's modulus. So it is not specified whether it is Euler's or Rankine's. Actually it is asked to find the Euler's formula. Let us calculate Rankine's formula also. Okay, for that take sigma c is equal to 40 Newton per millimeter square and alpha is equal to 1 divided by 750. Okay, now this is a rectangular section. Till now I have done circular cross section and hollow circular section and T section and I section. So let us take this rectangular section. For the Euler's crippling load, what is the formula? PE is equal to pi square EI divided by LE square. So here we want only I. So let us calculate first Ixx. What is Ixx? BD cube divided by 12 for rectangular section. So what is B? B is 200 and D is 300. So 200 into 300 cube divided by 12. That is equal to 450 into 10 raised to 6 mm raised to 4. Okay, now you have to calculate Iyy also. Least value you have to consider. How you can calculate Iyy? B cube D divided by 12 or dB cube divided by 12. That is equal to Iyy. What is depth? Depth is 300 and breadth is 200 here. So this is dB cube. Okay, so dB cube divided by 12. So 300 into 200 cube divided by 12, you get 200 into 10 raised to 6. Take the least value. So least moment of inertia of the column is Iyy, that is equal to 200 into 10 raised to 6 mm4. Now here in this problem it is given one end is fixed and other end is free. So what is equivalent length of the column? LE is equal to 2L. Okay, so what is LE? LE is equal to 2L. So 2 into 5000. Here you can write capital L or this. Okay, where is the pen? Okay, so here this is LE is equal to 2 into L. So 2 into 5000, length is 5000. It is given here, length is 1 meter long. So 2 into 5000, 10,000 or 1 into 10 raised to 4 mm. Okay, now Euler's crippling load, use that formula pi square EI divided by LE square. So what is that? LE square is here. This you can take it as LE. Okay, this you take it as LE and here also LE it is. Okay, so pi square into E is 17.5 kilonewton per millimeter square. So 17.5 into 10 raised to 3 Newton per millimeter square into 200 I into 10 raised to 6 this. So divided by LE square, this 10,000 square. So you get 345.44 kilonewton. This is Euler's crippling load. We have to calculate Euler's safe load, that is Euler's crippling load divided by factor of safety. Here factor of safety is given as 2.5. So you get 138.2. Now I have calculated for Euler's safe load. Now same thing you calculate for Rankine's load. How you have to calculate? You have to use Rankine's crippling load formula. PR is equal to sigma CS into A divided by 1 plus alpha into LE divided by K whole square. Okay, substitute the values. You have to find A also. What is area? Rectangular section area is equal to B into D. So once if you get area and moment of inertia, you can calculate what is K. K is equal to square root of I divided by A. So then you can find uh, this you Rankine's safe load. I hope you can do that. So you do that. Let us go to the next problem. That is compare the crippling loads given by Rankine's and Euler's formula for strut 2.25-meter long, having outer and inner diameters of 37.5 mm and 32.5 mm, loaded through pin joint at both the ends. Take yield stress as 315 meganewton per millimeter square. Alpha is equal to 1 divided by 7500 and E is equal to 200 giganewton per meter square. Here you have to calculate both Euler's and Rankine's. Then you have to compare the loads. In addition to that, one more question is there. That is, if elastic limit for the material is taken 200 meganewton per meter square, then for what length of the strut does the Euler formula cease to apply? Okay, so means here the stress is given, elastic limit is given. You have to calculate what is the length using Euler's formula. Okay, let us write first what are the given values. Let the outer diameter capital D is equal to 37.5 here, and inner diameter small d is 32.5 mm. Then length of the column, that is here it is given as 2.25 meter, so 2.25 into 10 raised to 3, so that becomes 2250 mm. Now sigma cs is given 315 meganewton per meter square, or 315 sorry, it is not 315, it is 3.5. So 3.5 into 10 raised to 6 Newton per millimeter square. So it becomes 350 Newton per millimeter square. It is mega Newton, so 10 raised to 6 Newton per meter square, or this is 315 only, not 3.5. Okay, this is 315, correct. So 350 Newton per millimeter square. Now alpha is given, that is 1 divided by 7500, and E is 200 giganewton per meter square, or 200 into 10 raised to 9 Newton per meter square, or 200 into 10 raised to 3 Newton per millimeter square. Okay, let us calculate first area. Area is equal to, it is hollow circular section, so pi divided by 4 into capital D square minus small t square. So what is capital D is 37.5 whole square minus small g is 32.5 whole square. Simplify this, you get 274.89 millimeter square. Next, calculate I. I is equal to d raised to 4 minus d small d raised to 4 into pi I divided by 64. Okay, simplify this, you get 42.31 into 10 raised to 3 millimeter to the power 4. Okay, now once if you know A and I, you can calculate what is K, that is equal to square root of I divided by A. Radius of gyration, K is equal to square root of I divided by A. I is 42.31 into 10 raised to 3 and area is 274.89. You get 12.41. Now you can calculate what is Euler's crippling load. Euler's crippling load is pi square EI divided by LE square. Here LE is equal to L because both the ends are pin joint or hinged. So substitute that value here, pi square into E is 200 into 10 raised to 3. I is this 42.31 into 10 raised to 3 divided by LE square, that is 2250 whole square. You get 16.49 into 10 raised to 3 Newton. This is Euler's crippling load. Then calculate Rankine's crippling load, that is equal to sigma Cs into A. What is divided by 1 plus alpha into LE divided by K whole square. Substitute what is sigma S. Sigma S is 350 into area is 274.89 divided by 1 plus alpha. Alpha is 1 divided by 7500 into LE divided by K. LE is equal to 2250 divided by 12.41 whole square. Simplify this, you get 16.078 Newton. Or yeah, it is 16.08 into 10 raised to 3 Newton. Okay, or this is kilonewton. Okay, so either this is kilonewton, this is kilonewton, so that is nothing but 16.078 into 10 raised to 3 Newton. So now you have to compare the crippling loads given by Rankines and Euler's. So let us take Euler's divided by PE divided by PR. What is PE? PE is 16.49 into 10 raised to 3 divided by 16.078. So you get 1.026. So Euler's crippling load is equal to 1.026 times of Rankine's load. Okay, this is the comparison. After that, second part you have to do, if elastic limit for the material is taken as 200 meganewton per meter square, for what length of the strut does the Euler's formula is to apply? Now we know that stress Euler's load is equal to pi square EI divided by LE square. Stress is equal to, all of us know, that is load divided by area. So stress is given here, that is elastic limit of the material is taken as 200 meganewton per meter square. So that is 200 into 10 raised to 6 Newton per meter square, or 200 Newton per millimeter square, is equal to load. Now you have to take Euler's load, because in this question it is asked Euler's load to see that what length of the strut does the Euler's formula is to apply. So use the Euler's formula. Load is equal to pi square EI divided by LE square divided by area. So when you simplify this, it comes like this. Okay, now 200 is equal to pi square EI divided by LE square into E. So substitute the values, or write in terms of LE. We want the LE value. So LE is equal to, LE square is equal to pi square EI divided by 200 into E. Okay, this LE goes here and 200 comes here. Simplify this. Pi square into E is 200 into 10 raised to 3 into I is 42.31 calculated value into 10 raised to 3 divided by 200 into area is calculated to 74.89. So you get LE is equal to 1232 mm. So here in this problem both the ends are hinged. So LE is equal to L. So LE is equal to 1232. So you can say that what length of the strut does the Euler formula is to apply, means that is equal to L is equal to 1232 mm. Okay, like this you can calculate, can compare the Euler's and Rankine's critical load or crippling load, and also to calculate the length. I hope all of you understood. If you have any difficulties, we can discuss in the class. Thank you.